hands-on part, right? So every Tuesday, what we do, we have Python hands-on sessions on YouTube Live, of course. Now, while you're watching this video on YouTube, I request you to subscribe to our YouTube channel. Of course, if you like this video, please like the video and share it with your friends. So, talking about today, the topic for today is AI design with OP. Of course, we'll be renaming it in that way, API design with OP. I'll just rename it. Now, what is the concept that we'll be covering here for today? We'll be covering concepts of course, basic OOP principles. Let me just take my pen. Yeah. So we will be talking about OOP principles. We'll be talking about API design. And we'll be talking about real world relevance. Now, when we talk about API design with OOP, of course, API we are talking about is again application programming interface, API, and of course, what we need to do, we are design it using OOP. Now, first of all, let's start to talk about the API, the OOP principle that we'll be covering. So first of all, let's talk about OOP principles that we'll be covering today. Of course, we have seen this previously, and we had been to the session regarding OOPs, object-oriented programming. OOP, of course, is object-oriented programming. So OOP principle that we'll be covering here today is encapsulation. When we talk about encapsulation, of course, we'll be using a model handler here, where all the OOP model related logic will be stored or encapsulated here. Now, one more concept that we'll be covering today is modularity. Modularity, of course, we will be taking API and model logic. Of course, we will be decoupling it. Yes, I have forgotten with my pen. We'll be decoupling it, of course, for easier maintenance. Right. Now, OP principles, of course, we discuss what we'll be discussing here. Second part that we will be discussing is API design. API design, of course, we will be using fast API here. Please. Fast API here. Now, why are we using fast API here? Because we will be using fast API because it provides an intuitive framework. Provides an intuitive framework for defining REST endpoints, right? Of course, we'll be using a library called Pydantic. And Pydantic will ensure that we have data validation for inputs and outputs. Now, talking about real world relevance, that is the third point. Talking about real world relevance, of course, we will demonstrate how to structure a scalable API for ML models. We'll see how to structure scalable API ML models. Of course, now when we talk about this, of course, we will talk about modular code that supports easy updates such as switching to deep learning models, etc. That can be done. Now, let's start with the coding part. So, what we will do is, first of all, we will install, let me just pip install fast API and UVCon and scikit-learn. For this, since we are doing it on Jupyter, of course, we don't need to connect with this, right? Yeah, pip installing it. Let's just continue till that time. Of course, we'll import all those libraries that will be required. For example, from Fast API, import of course, we have all these requirements satisfied. We'll pivot from Fast API, import Fast API. Of course, we'll have HTTP exceptions. HTTP exceptions. Right. We'll have Pydantic. Import this model. Yeah. We want from sklearn. From sklearn. Estimating. Import linear regression. Say longer data sets. We'll try to import this. Of course, we have two more libraries, basic libraries, for example, NumPy, SNP. And we will import pickle. Right. We'll just run it. We'll try to import these. First of all, we'll start with the first step. Step one. Step one is, of course, capital. Step one is basically we'll be making data and model class. Let's start with making a class first. We'll make a class called model handler. Of course, while making a class, we'll make a constructor. Of course, we define init. Self, we've already seen in the previous videos how we actually make the class. Right. Now, so define init. Sorry. Now, we'll say self. We'll say self of model is equal to none. Right. The same, we will define model. Of course, class is self. First of all, we'll try to generate synthetic data. Let's say we have y. Say make regression. Of course, we'll take different parameters. For example, underscore samples. Saying this is 100. Underscore features. We say it as 1. There's a noise. 0.1. Say we have random state of this minute. Random state equal to 42. Now, random state, of course, we are saying make regression and we are giving all these values. When we talk about random state we make sure to give to produce or to reproduce, right, for reproducibility. Now, let's move further. For example, we'll say self.model equal to linear regression, of course, in our capital. We have self of course dot fit fitting the model based on X and Y. Add is capital X, of course, that we have taken, small y, and we are saying self save underscore model. Now, we'll do one thing. While we are making this, we'll define save model self. Of course, we will be doing that to save model to the disk. Save it, open. Model.pkl. Of course, what we will do, we'll give a right binary. Right binary, if we give, this is very, very clear, WB. Right binary, when we are giving, we all know we are overwriting it for whatever we have. And with open right binary, we'll just save it as pickle. Pickle dot dump self dot model and f self dot model and f, and we'll say okay. Now define to load the model. Predict using the loaded model. Let's say if self dot model self dot model is none. Of course, so we have to give colon. We'll say self dot load underscore model and we'll make sure that we return self model predict self model that predict. And what do we need to predict? Of course, whatever will be the input data. Input data we're taking into consideration here. Input data. Yes, yeah. Okay, that would be a problem. Now, this is step one, where we made data and model class. Here we are making model to train the model, defining a trained model. We are taking linear regression. We are saving the model, and we are saying how to save it. Of course, save it as open. Just save it as model.pkl as a pickle file, of course. And we are saying load the model. When we are saying load model and bracket self, we say that we have to load the model, and if load the model, the safe mode load model, safe mode self model is none. Self dot load underscore model will return the prediction on the input data. Now, you have defined the class here. What we need to do is we need to make sure that we have step two. Of course, we want API schema for request and response. So we'll say step two. is API schema request and response. Now, let's make a class first. Sorry, to take class. We make a class, of course, request. Sorry for that. We'll talk about feature. Of course, let's say it's float. Of course, we'll be taking single feature input, right? For simplicity, of course, simplicity of the model. Now, we'll make another class. One more class we'll make, and that is prediction response, right? We prediction request we talked about. We want to make one more class for prediction response. Prediction response. Right. This model. And of course, the same thing we'll do. Prediction. And the feature we float we give. Prediction also we'll keep it as float. Right. By a float. This float we want. Now we'll talk about the third step, that is API definition. We'll define the API here. The definition will say app equal to make fast API. Sorry, fast API. Of course, I'm saying title equal to, let's say, okay, we'll make a model. So API OP is the name of it, and we are saying okay for version is nothing but, of course, 1.2 we are making, right? 1.2 is the version. So we have made the class of model handler. We have made the uh, class model handler, and now we'll initiate it or initialize it. Now let's take it and make an object. Of course, we have made a class. We'll initialize the model handler. Of course, we are giving it model handler. Also, sorry, I have it capital M and capital H. Yeah, of course, and we are making an object. Now, we'll see what we want to do on what we want to do on startup, right? So we'll see, right? App dot event. Okay, we'll do one thing, team. It's already we're already running late. I don't think we'll be able to complete it today. We have initialized the model handler. Okay, we'll do one thing. I'll run this, and if we have anything, we'll just I guess there's one issue and 22 return model that predict. Hmm. Oh, for the model I made a print of. Okay, it seems this is predict basically. You have to load the model, just predict the model. Fault. This is the model. Predict you may be making it, right? And of course, it's not just itself, and then input data. You have to meet the model. We will be doing it differently. Data, of course, we have to give. Right? We're predicting it, and I forgot. Sorry for that. So self input data. Let's say it's input dot nd array. So of course, we'll make this. Before this, of course, we have to make one model. Let's see. Now we'll define load model define load underscore model. It's itself. Now we'll use try and accept. Try. With open model.pkl. Of course, we have to get as read binary. Yes. Read binary, and we'll define the model. F. Self dot model equal to pickle dot load. F. So it as F, and we have to give exception. Except save file error. Of course, we'll raise exception. Raise. We'll say HTTP exception. Let's say status code. Sorry, it's not capital S, it should be small s. Detail equal to, of course, when we are making an exception, model, right? So we will make this change. So what we'll do here is we are actually loading the model. So what we have made. Okay. We'll train the model, save the model, of course. We'll load the model, we'll predict. Let's make this, let's do this now. Still having this problem. Missing fields. So sorry. For data we need to give. And yes, we successfully run this code at the very same time. We have just made the API definition. Now what we need to do is after this we have initialized, we need to define startup event and all those things. We need to make sure that we do the path and we will see that in the next part next Tuesday, right? So till the time team, I hope everything is clear. We discuss what we are going to do, what we are planning to do, and we discuss all those things here. Right. So we'll meet again next week and we'll continue from here. Until that time, team, take care. Rock again. Please do subscribe to our YouTube channel. We'll meet again. Take care. Bye. Good night, team.